There are a lot of things you need to consider. I'm not an expert, so I don't know all the details. What I can do is to make sure you know the physics of it. So the time it takes is omega divided by alpha. Let's simplify the system into a uniform rod with length L, and you are just applying a constant force. Because the force comes from the motor and the wheel. I don't think there's that many brand of wheel you can choose from, so when you are designing the system, you pretty much just say, all right, this is the wheel you can have. So the force is fixed by the company. You can really choose how big a force you want. And the material, which is the pipe, should be fixed. You can ask them to build a longer pipe, but this radius of the pipe is fixed because they need to make the pipe with this production line, which only have big machine and a size that is fixed. So the characteristic of the pipe is the mass density. This is lambda, another Greek letter, which we are going to use as the linear mass density. So if the pipe is uniform, will the mass of the pipe be bigger or smaller when you increase the length? Will longer pipe be heavier or lighter? Heavier. Yeah, so this is how much heavier it's going to be. If your pipe is length L, then the mass of the pipe will just be the linear mass density times the length of the pipe. That's linear mass density. Okay? So usually the company will have a fixed linear mass density for the pipe. What you can choose is basically just how long you want your pipe to be and how big of the circle you want each of the circle to be. Okay? So what we're going to do is to see how the length of the pipe affect this time it takes to reach the desired angular velocity. And you learn that torque equals I alpha. So you can move alpha here. 1 over alpha equals I divided by torque. So this will be omega I divided by torque. Okay? So now, if the length of the pipe is L and you are pushing with force F, you are always pushing perpendicularly because the direction of the wheel is fixed. How big is the torque? You have distance L, you are pushing with F as a force. This force will cause the torque by how big? What is torque? Torque will say something, and if you apply something here, it's harder to rotate. If you apply here, it's easier to rotate. So the longer the distance, the bigger the torque. So you know L should be in there. And of course, if you push harder, the torque should be bigger. So what will be bigger if L and F is bigger? Torque. Yeah, and how do you combine these two? So torque will be bigger when they are bigger. Multiply. Yeah, so you multiply. The torque in this case will just be the length of the pipe times the force. Okay? So now the only thing we don't know is how the moment of inertia of this pipe will change. If the force is not perpendicular to the lever arm, you take the sine theta. But if they are perpendicular, torque is easy. It's just the lever arm times the force. Any question before we start calculating the moment of inertia of this pipe? Alright, so this pipe is a system. It has a lot of particles in there. And for a lot of particles, we need to add all the moment of inertia of all the particles. So, what we're going to do is cut this rod into many small intervals. And then we can treat each small interval as a particle. Okay? What we're going to do is to cut it into n particles. So you will have R1, R2, R3, all the way to Rn. Okay? Rn is the nth particles distance to the pivot. Right? So if the total length is L, then what will be a distance for a segment? You cut the entire length into n segments. So R1 will be how long? If you cut L into half, R1 will be
L over 2.
good. So if you cut L into n segments, how long will R1 be?
L over n.
Good. Good. L over n. Does that make sense? Now, R2 is one segment longer than R1. So one segment is L over n. R2 is two segments away from the pivot. So how long will R2 be?
2 L over n.
Good. And you can do this all the way to the nth segment, which will be NL over n. Okay? Now, we are looking at a uniform rod. Which means that this linear mass density will not change along the rod. It is uniform. So, when you want to look at the mass of individual segment, you just multiply the linear mass density with how long that segment is. The first segment is having a length L over n. How about the second segment?
Lambda 2 L over n.
So is the second segment longer?
Yeah.
The distance it is from the pivot is longer, but the length of the segment itself is the same. We are cutting the rod into n equally long segments. And if we want to look at the mass of this part, we are just looking at the length of the segment, not the distance to the pivot. R here is the distance to the pivot, but when we look at the mass of this part, we only care about the length of this part itself.
Why don't you count the mass for like the whole length part of it?
Good, because I'm looking at the mass of just this segment. I am cutting this rod into n small particles. Each particle has their mass, and I cut it equally long, so all the mass is the same, which is just the total mass divided by n, or the linear mass density times the length of a small segment. Okay? So all the segments have mass L over n. L over n times n, you need to times n. we are ready. What we need to do is add all the mass and radius square, and then we get the moment of inertia. Okay, and we know that the distance that each particle is away from the pivot just grows with the number of particles you're looking at, and their mass is all the same, it's just the total mass divided by n. So the moment of inertia of this rod will be m1 r1 squared, m2 r2 squared, all the way to the nth particle, and m1, m2, m3, all the way to mn is going to be lambda L over n. So I'm going to take it out of the parentheses. Okay? What is left is this r1 squared. R1 squared is L over n squared. So L over n squared. R2 will be twice as long. And you add it all the way to n L over n squared. Okay? So if you look at all the terms in there, they will have L squared divided by n squared. So I can take them out. They all have L squared divided by n squared. So if I take away L squared divided by n squared, what will be left for the first term?
1,
Good. And what will be left for the second term?
2,
2.
L4.
Yeah, that's right, as 2 squared and 1 squared. So the term in there will just be 1 squared plus 2 squared plus 3 squared all the way to n squared. Okay? So I can read lambda, it's just a linear mass density. I can count L squared, there's going to be 3L. I can count n is a big number. But I don't know how to do the sum.